Okay, let's pretend we are going to design our first study. Who's the study about? First, we must determine what population we want to study. It is critically important that we define the population in advance and write it down. Then we think about whether we can do a census or whether we must do sampling instead. Okay, what do we want to know? Well, to gather the information, we're going to formulate questions that will help us gather the data. Questions or interviewers that influence the outcomes lead to response bias. For example, do you really like that shirt on me? It's very different from, do you really like this shirt on me? Tone of voice can make a difference. Wording makes a difference. Everything makes a difference. Questions should be objective. We should be very, very careful to minimize bias. We are good researchers. Here's an example of response bias. Before I grade your test, complete this survey on my performance as a teacher. Yeah, are you going to give me a bad review before I've graded your test? I think not. Now, from whom do we gather the data? When a census is too difficult, too expensive, then we must do sampling. The sampling frame, important vocab word, sampling frame. It's the pool of possible participants. If there are folks in the population who are not in the sample frame, it leads to undercoverage and gives us a source of bias. Now, we are sure to use randomization in your study. If I let individuals volunteer for the survey, wait, my individuals in general have to volunteer for the survey, but I can randomize them and minimize that bias. If I only choose out people who volunteer, it's likely they won't be representative of the population. There's a name for that. It's voluntary response bias. Okay, the timing of surveys can have a big effect on non-response, meaning there's nobody around even to answer your survey. You know, if I'm doing a survey of Stony Point seniors, not likely it's going to be a good idea to work on senior skip day or use any method that is easily ignored. I put a stack of surveys in the front office. I put a stack of surveys in the cafeteria. Who's going to see those? Who's going to pay attention to those? Holy cow. Now, let's say that we are going to construct a completely randomized experiment. We choose our subjects from our sampling frame. We use randomization to get folks into group 1 and therefore into treatment 1. Other folks go into group 2. They receive treatment 2. In general, one of these must be a control group, and every other variable needs to be the same for all the groups. And we have a look at the response variable to compare what's the same or what's different between the two. Now, sometimes we use a block experiment. The reason that we would want to use a block experiment is that we are looking for something that is different between two groups. African American versus European, Caucasian, or men versus women, or little kids versus teenagers, or adults versus senior adults. There can be all kinds of reasons that you might want to see whether a medicine works differently in one group than in another. In that situation, block 1, let's say African Americans, they are put into one group. They are randomly assigned to group 1 or group 2. We see what the results are. Our second group might be Europeans, Caucasians. We divide these folks randomly into two groups. The treatment 1 and treatment 2 are the same, and we see whether the results between the two treatments are the same or whether they're different. Now, in a block experiment, we look at the results from block 1 and we compare them to the results for block 2. They're either going to be statistically significantly different or not. And from there, we can possibly draw some conclusions. Blinding. Blinding means that somebody does not know what's going on. Blinding prevents bias by hiding the type of the treatment from the observer or the subjects. If you blind one side, it's obviously single blind. If you blind both sides, it's double blind. Wait, why would you do a single blind study? Let's say that you want to do the Coke versus Pepsi challenge. The observers, the researchers, would want to know whether the subjects are sipping Coke or whether they're sipping Pepsi. The subjects can't know because they might try to influence the results of the experiment. In a double-blind study, which is much more common when looking at drug trials, nobody except the statisticians and the clinicians in the home office or the pharmaceutical company, nobody knows who is getting which treatment. Why? Because if I know that the patient in front of me is getting a placebo, it's human nature for me not to look for any differences in that person's behavior or any of the things that I can measure. On the other hand, if I know that my patient is getting the new drug, then I may just be influenced that that new drug is really working, possibly better than it is. And of course, the patient is very, very likely to see that if they knew they were getting a placebo, they would downplay any improvement. If they were sure that they were getting the drug, they would be all excited, exaggerate, and possibly overestimate the level of improvement. Double-blind is almost always used for drug trials. A single-blind study might be more useful in a marketing context. Thank you for your time.